Today's objectives are recognizing points, lines, line segments, rays, angles, and triangles, and learning how to use proper notation with each. A point is a place in space. It has no length, width, or height. We use capital letters to name points. When we place points side by side, we begin to see the formation of a line. In this class, all lines are straight and extend infinitely in both directions. At this time, I'm going to introduce our first axiom. It's a postulate, and it reads, any 2 points determine a line. In our proof writing next week, we can write this as 2 points implies a line, which could be read, if you have 2 points, then you have a line. Let's take a closer look at this middle diagram, the one containing points B, C, and D. In the list noted in the second bullet, they have 6 different names for that particular line. Notice that they've chosen any 2 points in any combination. Notice in particular the notation above the 2 points. That is imperative that you use the 2 arrows to show that that is actually a line. If we take a line and choose any 2 points, let's say points A and B, and then cut it at those moments, then we get a line segment. A line segment is named by its endpoints. Take a look at the notation used above segment SR. It does not have the arrows. Similar to a line, we can look at a ray. A ray has one and only one endpoint. A ray is different from a line or a segment in that it begins at an endpoint. If I have a point and I lay an infinite number of points directly next to it, only in one direction, infinite means it would go on forever, then I have a ray. And there's an infinite number of points on that ray. So to name it, I'm going to choose the endpoint, always start with the endpoint, and then any other point on that ray is fine. When 2 rays share a common endpoint, it forms an angle. So I could name this angle cat or tack. I cannot name it angle ACT because C is not the vertex. The vertex or the common endpoint is always the point in the middle. I would not want to call it angle A like your book suggests, although if I said angle A, this is the only A in the diagram, so that would be kind of clear. But in the future, your diagrams will be much more complex. So if I throw another ray in there, I'm not sure if I'm talking about angle BAC, angle BAT, angle CAT, if I just say angle A. So I'm going to discourage you from doing that. You could number your angles. A triangle is the union of 3 segments. Union means to join. Intersection is overlap. So AC intersects segment BC at point B. Union and intersection in math is connected to Boolean algebra or set theory. Union is an English equivalent to or, and intersection has an English equivalent of and. And actually, I misspoke a little bit there. The English word or is ambiguous. It could be inclusive or exclusive. For example, if it's exclusive, I could say, what would you like for a side? Would you like green beans or mac and cheese? So you can have one or the other, but not both. Would you like to go to a movie or to the dance? You can do one or the other, but not both. An inclusive example of or is at an all-you-eat buffet, where you can grab chicken and ribs or chili or whatever else strikes your fancy. So you could have both. Or I could say, you could do your homework in pen or pencil, where both would be acceptable, even though you should only be using pencil in real life. But in math, union, which means or, math, it's strictly inclusive. Anytime you hear the word or in math, it's inclusive. It means join everything together. So in a union example, you want to trace with one color. So if I were to ask my ride, if I were to call for a ride at Marquette High, and I said, could you please pick me up on 35th Street or Wisconsin Avenue? That would cover quite a bit of distance, wouldn't it? I don't think my ride would know where to find me. In contrast, intersection is and. So if I were to ask to be picked up on 35th and Wisconsin, this is 35th Street. This is Wisconsin. When I say 35th and Wisconsin, I'm specifically talking about that overlap right there. So for an intersection problem, you want the overlap. Your textbook does provide some examples of union and intersection. So where does ray AC intersect with line BC? So ray AC is from point A in the direction of C, and line BC extends infinitely in both directions. So now where that overlap is technically from this point and everything in that direction. So that would be ray, you could call it ray AB or ray AC. The next example is what is the union of ray BA, union is one color, and ray BD. So when I join that together, I get angle ABD. Another one is asking, draw a diagram in which the intersection of ray AB with ray CA, so starting at C in the direction of A, is segment AC. Ray KM, should use a different color, sorry. Ray KM in union with. Union is to join. So think of this as like maybe a salad bowl where you can dump everything in. And then ray KJ. So the union of those is going to be angle MKJ. The union of segments CD, DB, and CB, when I join those together, I get a triangle. So that's triangle, and then the order at this point doesn't matter. Charlie, David, Ben. That's a little different from the intersection examples where we should use two colors and look for the overlap. So if I look for ray KM, starting at K, going to M, and that can go on forever. and that intersects with ray kj, that only intersects at that one point, point K. Let's review some algebra. Last year, you should have learned a 5-step plan. It may have been called something different, but essentially you were asked to write a diagram, define your variable, write an equation, show your work, and then answer the question. In triangle ABC, segment AB is twice as long as segment BC. So whatever's mentioned second here, segment BC, I'm going to call that X. And then segment AB is twice as long as that. So that's 2X. Segment AB is exactly as long as AC. So I'm going to also name that 2X. Done with the first sentence. Now reading the second sentence, if the perimeter is 20, find the length of each side. So the perimeter is the distance all the way around, the sum of the sides. 2 plus 2 plus 1 gives me 5x's. The perimeter is means equals, and that's 20. Now to isolate the variable, I need to divide both sides by 5, which means x is 4. So now I'm done, right? No. Find the length of each side. BC is 4. 2 times 4 is 8, so that's how big AC is. And then AB is also 8. And I can check my work. 8 plus 8 is 16, plus 4 more is indeed 20. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.